Soil pH is just one of those really critically important soil properties that falls between a range of 1 to 14, with 7 being neutral. If you happen to have a pH of 5, what that means is that relative to a neutral pH of 7, it's actually 100 times more acidic. Every soil sample that comes through the lab gets soil pH measured on it. And over the last 21 years that I've been here at the lab, we've seen some really interesting trends with our long-term rotation treatments. Namely, we're seeing the greatest acidification under our 3-year crop rotation. But it's not just necessarily annual cropping, because we can crop using a dynamic crop rotation and actually see less acidification. And in fact, the same degree of acidification relative to a crop fallow, where we're applying nitrogen every other year. So there's some efficiencies there with the crop rotation sequencing that we don't have in other annual cropping systems. However, it's important to point out that all of our cropping systems are really becoming more acidic over time when we compare our pH values relative to our long-term grazed pasture, which is it's sort of historically native, fairly stable soil condition. You can see that we've dropped to 1.5. Places we're like 100 times more acidic under dryland cropping. This is important because we're going to have to think about interventions to mitigate that acidification, because it can have an effect on nutrient availability. It can certainly affect our ability to cycle those nutrients efficiently, and in the end, it's going to affect your crop yield. And so it's something we have to look at really carefully, and that's going to be sort of the topic, is understanding ways that we can perhaps mitigate acidification and also find ways to ameliorate it so that you don't have to suffer yield losses, and we don't have to really further degrade soil quality from a chemical solution standpoint.